In section 10.5, we're going to talk about independent and dependent events and how they relate to probability. So compound events may be independent events or dependent events. Events are independent events if the occurrence of one does not affect the likelihood that the other event will or will not occur. So it's important to understand that in an independent event, when something happens, it will not affect anything else that happens. So your key idea will show you this: the probability of an independent event. In words, the probability of two or more independent events is the product of the probabilities of the events. All you do is this. If you have to find the probability of event A happening, then event B, you find the probability of each and multiply them together. The same thing if you have three events that don't affect each other. You would find the probability of one, multiply by each of the others. So example number 1, the probability of an independent event. If we spin the spinner, which looks like a flower, and flip a coin, what is the probability of spinning a prime number and flipping tables? Well, here's what we need to understand about an independent event. If we are going to spin a prime number and then flip tails, spinning the spinner does not affect the outcome of flipping the coin. So because each event is separate and does not affect the other, each event is independent of the other. So when we start this, we're going to do the probability of spinning a prime number. So we first have to identify all the prime numbers. Well, 1 is not prime, 2 is prime, 3 is prime, 4 is not prime, and 5 is prime. So we need to know that there are 3 prime numbers out of 5 possible outcomes. So our probability of spinning a prime number would be 3/5. The probability of flipping tails is 1/2. So the probability of both events, which this is our formula, we would plug that in as the probability of prime and tails, would be multiplying them together, 1/2 times 3/5, which equals 3/10, or we could write that as 30%. Now we're going to talk about dependent events. Events are dependent events if the occurrence of one event does affect the likelihood that the other events will occur. So in words, the probability of two dependent events A and B is the probability of A times the probability of B, but after A occurs. So we write that as the probability of A times the probability of B after A. All right, so now we're going to talk about the probability of a dependent event. People are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first, and then one of your friends is chosen second? Well, here's what we have to look at. Choosing an audience member will change the number of audience members left. So the events are dependent. So if we have 100 people and one person is chosen, that affects how many people are left. There's now 99. So it is going to be a dependent event. So the first thing we do is the probability of picking a relative. Well, how many of them are relatives? There are 5. Out of 100, which would simplify into 1/20. So the probability a relative will be picked is 1/20. Then we're going to do probability of a friend, but this is after a relative was chosen. So how many friends did you bring? You brought 6, but there are no longer 100 people. There are now 99. So 6 99ths simplifies into 2 33rds. So the probability of a relative and then a friend after the relative is chosen would be 1/20th multiplied by 2/33, which would give you 1 divided by 330, not 333, or about 0.3%. So let's look at our last example, finding the probability of a compound event. So you're taking a test. This test is on, let's say it's history, and a student, or you, randomly guess the answer for each of the following multiple choice questions. What is the probability of answering all 3 questions correctly? Well, here are our 3 questions. 1, 2, and 3. What is the probability that you would answer each of them correctly? Well, first of all, it's an independent event because any answer that you choose for any one of the questions will not affect the outcome of any of the others. So this is an independent event. So the probability of answering number 1 correctly would be 1/5, 1 correct choice out of 5. The probability of number 2 would also be 1/5. And the probability of answering number 3 correctly would also be 1/5. So we would take 1/5 times itself 3 times, which would give us the probability of 1 divided by 125, which is 0.8%. So the probability you would actually answer each of these correctly would be 1 out of 125, or 0.8%.